Welcome to question 10 of the year 12 PPE. So in this question we're given a cubic function g of x and we're asked to use the factor theorem to show that g of x is divisible by x minus 4. Okay, which means we would be working out g of 4. Now the first thing to say here is that that isn't true. It is not divisible by x minus 4. That's a mistake. It's very easy to see why, because if you did g of 4, okay, so in other words, you substitute 4 into that function for x, you would get an even number here, another even number here, this would be even, and that's odd, minus 21. So the answer would be odd, and of course 0 is an even number. So you wouldn't get 0, in fact it comes to 3. So g of 4 does not equal 0, okay? That's a mistake. It should have been a different number. It should have been 3 in the question, not 4. But there is another factor that you would easily spot, which of course is that x minus 1 is a factor. Because if we do g of 1, okay, g of 1, you can see hopefully that you would get 2 minus 15 plus 34 and minus 21, which equals 0. So by the factor theorem, that means that x minus 1 is a factor, okay? And if we use that, which is the easiest one to find, okay, then we can find the quadratic factor with it as well. So if you're asked to factorize a cubic, you always start by trying x equals 1 or 2, sometimes minus 1. And it's usually one of those numbers that gives you the first factor, and once you've done that you can find the quadratic one quite quickly. All right, so it should be x minus 1. That question should have been x minus 3, in fact, which is another factor. Okay, that's what it should have read. But we found x minus 1, and we're going to use that to finish the problem off. The other thing, of course, is you've got your graphics calculator, and if you took put that function into the graphics calculator and had a look at it, you would see that 4 isn't a root, 3 is, so is 1, and so it appears to be 3.5. Okay, and we'll show that in just a moment. So we're now going on to part B, where we've got to show all our working. Okay, so we can't use the calculator here. We've got to show our working to get the other factors. So we'll do a division. We'll divide. I'll take the x's out and just put the numbers in. X 1 minus 1 into 2, negative 15, okay, 34 and 21. Okay, so it's a long division, and we go into here twice. 1 into 2 goes twice. That makes 2 and negative 2. Subtract, and that will give us negative 13. Okay, bring down the 34. That will now give us negative 13 here. Okay, which goes in negative 13 and 13. Another subtraction will give us 21, which we were kind of expecting because we've got here, oh, this should be here a minus 21. Okay, so bring down that minus 21. Okay, and that gives us 21 minus 21, which is 21 times, and that gives us a remainder of 0. Okay, so there's the division process leading to a remainder of 0, confirming what we found in part A. By the way, you must use the factor theorem if it asks you to. So if we had just gone straight into this division to show that x minus 1 is a factor, that wouldn't be acceptable for that question because it explicitly asks you to use the factor theorem. Anyway, we've got that far, so we know that g of x can be written in this form. So g of x is equal to x minus 1, and that's multiplied by the quadratic that we've just obtained, which is 2x squared minus 13x plus 21. Okay, and that quadratic further factorizes, well, we already know that from the graphics calculator, but we should still show it because the question is about showing algebraically, well, showing all your working, it says. So it's x minus 1, and then we've got 2x minus 7 and x minus 3. Okay, so all three roots are to the right of the y-axis, which you can see here. Okay, so that's the full factorization of g of x, which is what we were required to do for question B. Okay, so going on to question C now, the integration part. Okay, well, let's look at what it's asking us to do. It's saying that we've got to find the region R, which is bounded by the curve g of x, the x-axis, and lies below the x-axis. Okay, so it's this area in here. It's not a very big area. Okay, it's just that small area under there between 3 and 3.5. Okay, so to find that region R, I'll just label that R. Okay, so to find that region R, I need to integrate between 3.5 and 3. Okay, so I need to show the integration, because it says find using algebraic integration. So you've got to be really careful not to shortcut this and go straight to the calculator. So it's the integral between 3.5 and 3, okay, of g of x with respect to x. Okay, and I must integrate it without using the calculator. So I transfer from an integral sign to a square bracket, and term by term I integrate. Well, I'm going to raise the power by 1 and drop it, so it's going to be x to the 4 over 2, okay, or a half x to the 4. Okay, and then I've got 5x cubed. And then 17x squared. Okay, and finally minus 21x. Okay, and I must show in the in the closing square bracket the two limits, 3.5 and 3. Okay, now that's what they're looking for these marks, the recognition that you need to integrate to find the region, the correct limits, and a process of producing the integral algebraically without using the calculator. Now, for the substitution part, you can go onto the calculator at any point now and finish it off, okay? But what you must do is be very careful particularly with negative signs. But if you do that process of substituting 3.5 and then 3, that comes out to give you negative 3 over 32, okay? Negative 3 over 32. And you must put the negative sign in at this point because the integral is, the value of this is negative 3 over 32. Then you can conclude that the region R is 3 over 32 because of course an area is an absolute number. It's not requiring a negative or positive sign. Okay, and the reason you get the negative, of course, is because the area is below the x-axis. Okay, but the answer to the question is 3/32. And you don't need any units or anything in there. Okay, so that's question 10 done. Take care.